In this unit, we will be looking at the respiratory system and how gas exchange occurs in the body. The anatomy of the respiratory system can be divided up based on its location or its function. If we divide it by location, we have the upper and lower respiratory system. The upper respiratory system is composed of the nose and the pharynx. The lower respiratory system is composed of the larynx, trachea, bronchi, and lungs. You will often hear these used to distinguish between upper and lower respiratory infections. If we divide them on function, we have the conduction portion and the respiratory portion. The conduction portion includes all of the tubes, the nose, pharynx, larynx, trachea, and bronchi. The respiratory portion is where gas exchange occurs in the lung tissue itself. This illustration shows the major components of the respiratory system. The nose is used to warm the air we bring into the system. The external nares are the nostrils, and the internal nares are the internal openings which connect to the throat. In order to be able to see the internal nares, you would have to take the nose off the face. The nasal cavity is located inside the internal nose in the space above the mouth. It is divided into right and left portions by the nasal septum. The pharynx is the throat and is divided into three regions. The nasopharynx is the upper portion of the throat next to the nasal cavity. It contains the pharyngeal tonsils as well as the eustachian tubes. The oropharynx is the middle portion and contains the palatine and lingual tonsils. The laryngopharynx is the lower portion. This is where the esophagus connects to the trachea. The larynx is the voice box. It is located approximately at the level of C4 to C6 of the cervical spine. It has several cartilages that make up the walls. The anterior wall is the thyroid cartilage, and it is made up of hyaline cartilage. The epiglottis is elastic cartilage at the upper portion, which covers the trachea. The cricoid cartilage is made of hyaline cartilage and attaches to the first ring of the trachea. The arytenoid cartilage sits above the cricoid cartilage and attaches to the vocal cords and the pharyngeal muscle. This cartilage is involved in voice production. The trachea is held open by hyaline cartilage rings and is lined with simple ciliated columnar epithelia, which you can see in this illustration. Superior to the vocal cords are the false vocal cords. These are the upper folds of the mucous membrane of the larynx. They are not involved with sound production, but allow us to hold our breath to build thoracic pressure, such as when we cough, sneeze, or bear down. Just inferior are the true vocal cords. These are elastic ligaments which will vibrate to produce the sound waves of our voice. As we increase the pressure, it will increase the volume of the sound. As the tension is increased, they will produce a higher pitch sound, just like a rubber band. The vocal cords are longer and thicker in males, giving them a lower pitch voice. The trachea is the tube carrying air to the lungs. It is held open with the hyaline cartilage rings and lined with cilia that move particles up to be coughed up and removed from the airway. The bronchial tree branches like a tree, with the trachea being the trunk. It will then split into two primary bronchi that go to each lung. These branch to form the secondary bronchi and the tertiary bronchi in each lung, and then to form the bronchioles and terminal bronchioles. These illustrations show several of the structures in the respiratory system. You can see the bronchial tree on the left side is slightly more horizontal in orientation. This is to accommodate the space for the heart. The lungs have a series of membranes. The parietal pleura lines the cavities the lungs are in. The visceral pleura is attached to the lungs themselves and covers them. The pleural cavity is the space between the parietal and visceral pleura and must be kept airtight to allow breathing. The base of the lungs is the inferior surface and the apex is the top. The hilus is the place where the bronchi enter the lungs and sits below the apex, so air does actually enter in a little bit below the top of the lungs. The fissures are the spaces separating the lobes of the lungs, with 2 lobes on the left side and 3 on the right. The lobes are the regions of the lungs. The alveolar ducts are the small tubes that carry air into the alveolar sacs and provide a common opening into 2 or more of the alveoli. The alveoli or alveolar sacs are the sacs surrounded by a respiratory membrane for gas exchange. This illustration shows the alveolar sacs and the respiratory membrane. The capillaries surround the alveolar sacs, so the oxygen from the air is able to cross the single-layered membrane into the blood. The carbon dioxide waste is also able to cross to be exhaled out the same pathway. The respiratory membrane is the shared wall of the alveolar sac, the capillary. It is made of simple squamous epithelium, and on one side is capillary, the other is alveoli. This allows for easy gas exchange. In order to keep these delicate membranes from sticking to each other, the lungs produce surfactant. This is a lubricant that prevents sticking. This lubricant does not develop until 36 weeks of fetal development. The development of artificial surfactant has greatly improved the survival of premature infants. We're going to watch a little link on respiratory gas exchange produced by Wisconsin Online. This learning objective describes the basic mechanisms of gas exchange among the lungs, blood, and tissues. Gas moves from areas of high pressure to areas of lower pressure. The pressure of oxygen is represented as PO2. The pressure of carbon dioxide is represented as PCO2. The PCO2 in the pulmonary capillary equals 45 millimeters of mercury. PO2 in the pulmonary capillaries equals 40 millimeters of mercury. Here you can see the alveoli in the lung. Oxygen moves from the alveoli to the capillary entering the lung. Blood is now oxygenated. This oxygenated blood moves to the tissues to deliver oxygen and pick up carbon dioxide that is produced from cellular metabolism. Here is the whole process.